difference can be represented with respect to the clock generation. So the difference between phase 0 and phase 1 is represented by using a VHDL code for a phase shifted clock generation. So like this. So calculation of setup time, hold time representation, and clock tick event and the clock tick 0. Here a D flip-flop representation with VHDL by using a generic statement is represented in this particular program. Literal. Coming to the next next topic, literal. Integer literals may be expressed in any base from 2 to 16. Any two adjacent digits may be separated by a single underscore. So now examples are 1, 2, 3, 4, 3 base 10 integer literals and 2 hash base 2 binary integer literal and base 8 octal integer literal and hexadecimal for readability. So float next another representation, literals may be represented by means of floating points also. Okay, so by using dot. See 65971.333. So it is a floating point number. The representation, another representation of literal may be a character literal which consists of a single character and can be any character which can be entered. Now identifiers are the names and must follow VHDL rules for creating the names. So what are the various identifiers? Say for example, the A is an identifier, then A will be treated as a character. Character literals are case sensitive. Remember, in VHDL, character literals are case sensitive. When they appear within the model, then they must appear in a single code and they must be in the same case. Now, what are the identifiers? Identifiers are not case sensitive and can include letters, numbers and the underscore character. It must start with a letter and it cannot end with a underscore. Remember, it should start with a letter and it should not ended with a underscore. So this is the following these rules, many identifiers are there. Next, typing. Objects type determines objects type determine values it may assume and operations which may be performed on it. So data pass and object value aids in the design verification. There are in the design verification, considering there will be different data paths and different object values. Now what are the various classifications of type? Scalar type, composite type, file type and access or pointer type. So now the type of an object identifier, the values of identifies the values of the object that may assume. When a value is assigned to a signal, then the value is checked to be sure that it within the allowable set of values or not. If it is not, an error message will be issued. This is particularly useful for values assigned from a arithmetic computation. Now the scalar types. Scalar type, there is no structure including of all numeric, enumeration and physical object data type. Now the types which are made of real numbers, integers, quantities with associated physical units such as times and object that which are made up of character literals or identifiers which are all scalar types. Okay. So now considering what are the scalar type and range. Range identifies the subset of value and it may be used type declarations or object declaration. So range, begin, direction and end is the syntax. Now direction may be either ascending range or descending range. So now here 3 down to 0 or 2 down to 1 or 1 to 2 like that. So 1 to 2 if you are representing it is a 2 ascending nature and if it is 3 down to 0 it is descending type. Now type day, example is type day is range 1 to 31 like that. You have to represent the day 31 days. Now type voltage is range 12 down to minus 12 like that. Voltage representation between minus 12 to plus 12 range. Here we can represent. Now another example is signal in underscore volts, voltage, range 5 down to 0. So this is the object declaration within the range of subset for the full range of a voltage. So object representation can be given by means of a scalar or signal representation. Now considering the floating point type. Floating points are the unbounded set of positive and negative numbers which contain a decimal point. 32-bit limitation restricts the range, and here the upper and lower range constraints must contain a decimal point. Declaration format and the how to represent a floating point type is type real is range minus 1.7976 E 308 to plus 1.7976 E 308. So this is the representation of objects or identifiers. Another data type is enumeration type. Enumerated data types. The list of identifiers or character literals identifiers here followed a standard naming rules. So the declaration is a type underscore name is enumerated list. Here a predefined enumerated data types will be represented as follows. Type bit is. So it will take the data bit 0 to 1. Type boolean is. It will boolean value will take two different values, false comma true. Type severity underscore level is. Note, warning or error or failure. It may take four different types of severity levels. Now type character is. It will take the characters like A, comma B, comma C or up to Z you can give. Okay. So following these, the following are the various examples for representing the voltages, temperatures or enumerated data types. Now physical type. Physical type means the type underscore name is range underscore constraints. Here the basic units are, you can give various predefined physical type data are there, where the timing range is in between picoseconds, nanoseconds, millisecond or timing. You can represent physical data is a time unit or temperature or any other values you can declare within the specified format. So now in this example I have represented the resistance value. Say type resistance is range 1 to 10 power e power 9 units. The basic unit kilo ohms will be the 1000 kilo ohms and end unit.